Dear students, in this session, we'll study about electron displacement effect in covalent compound or electronic effect. Electron displacement effect in a covalent bond or electronic effects. We need to study about the electronic effects. What is the meaning of electron displacement effect in a covalent bond? We know that organic compounds, all organic compounds will be forming, means the electronegativity difference between the carbon and hydrogen or carbon and oxygen is less. Due to that, there will be sharing of an electron between them. So shared pair of electron between them, which forms a covalent bond. Organic compounds preferentially forms covalent bond. In covalent bond, there will be shared pair of electron. So due to the formation of covalent bond, the shared pair of electron will displace, changes its position either by the displacing the electron from one carbon atom to another or one carbon atom to other group by itself, or by any other attacking reagent in presence of attacking reagent, or by themselves. The displacement of electron will take place due to the attached group or atoms to the carbon or inorganic compound. So electron displacement will take place by themselves itself or with any other attacking reagent. We know that the attacking reagent may be an electrophile or a nucleophile. In the presence of electrophile or nucleophile, electron displacement will take place, or in the attached group to the carbon itself, any other group, the displacement of electron will take place. We need to study about in detail about the electronic displacement in a covalent bond. That is we call as electronic effect. This electronic effect is classified or divided into majorly the four types. In the first one, inductive effect. First one is inductive effect. So inductive effect is represented with a capital letter I, inductive effect. Second one is electromeric effect. Electromeric effect. This is represented with a capital letter E, electromeric effect. Third one is resonance effect. Resonance effect, it's also known as mesomeric effect. Mesomeric effect. This is represented with a capital R or a capital M, both the same, resonance effect or mesomeric effect. Fourth one is hyperconjugation. Hyperconjugation, or it's also known as Nathan-Baker rule, also known as non-bonded electron. Non-bonded electron. Okay, so these are the different types. These are the different types of the electromeric effect. So we need to be discussed the electromeric effect. Sorry, we need to be discussed the electronic effect. So electronic displacement effect. Why this electronic displacement effect we need to study? Because organic compounds will form covalent bond. Okay, formed covalent bond will be consisting the pair of electron due to the attached group of atoms, group or atoms with a carbon, or in the presence of any attacking reagent. Okay, electron will displacement of electron will take place. So due to this displacement of electron, so what will happen? So it shows an effect. Electron displaces, due to that will be noticing the effect. So displacement of an electron will be divided as inductive effect, electromeric effect, resonance effect, and hyperconjugation. There will be different kind. If attached group, whether it is an electronegative or the shifting where the attacking group are attached when the more electron density or less electron density, or the delocalization of pi electron, or in presence of so whether it is permanent effect or temporary effect of all these things we need to be discussed in the displacement of reactions. Okay, so electron displacement effect in a covalent bond. I hope you are getting what is electron displacement effect. Okay, so due to shade pair, due to the formation of covalent bond, electron will transfer, okay, displacing of an electron sigma or pi electron. So in some cases we'll be noticing the permanent effect, in some cases it will be temporary effect. So we'll be discussing the first one. In electron displacement effect, the first one is inductive effect. So the first one is inductive effect. What is inductive effect? Inductive effect is a permanent displacement of sigma electrons. Permanent displacement of sigma electrons towards more electronegative group or atom. So more electronegative group per atom. So inductive effect represented with a symbol I. Okay, it is a permanent displacement of sigma electrons. So carbon forms bond with other carbon or with some any other groups. Example, so carbon can able to combine with another carbon, can able to form long chain, is known as catenation. And to this carbon group, if any more electronegative group like halogen is attached to this carbon. If halogen attached to this carbon, what happened? Chlorine is a more electronegative than carbon. So chlorine will be having partial negative charge and carbon will be having partial positive charge. So in this case, so shared pair of electron from the carbon to a chlorine, it will be move towards carbon. So if they move towards carbon, we can notice that the shifting of electron more towards a chlorine in first carbon. So the shifting of electron towards in this carbon number 1, the shifting is more towards from carbon to chlorine. So Cl will be having negative charge and C carbon will be forming positive charge. Okay, this is the permanent effect. So what happens to the second carbon, third carbon and fourth carbon? So what happens to this? The tendency of dragging of pair of electron towards from carbon to chlorine decreases in second carbon. Okay, so it's decreases we represented with here no 4 of the arrow mark. I'll write 1, 2, 3 arrow mark, which indicates a little less compared to this carbon shifting dragging towards this chlorine will be decreases and here and further decreases. So what it will be indicates if carbon group will be consisting any more electronegative than the carbon, if it attracts the shade pair of electron towards themselves, then carbon will be having the positive charge and the other group will be having negative charge. Okay, so this is what they are saying. Displacement of sigma electron, we know that the sigma electron and pi electron, first most the basic bond what it forms is sigma and the next double bond is the pi bond. Okay, here the first bond itself, so in first bond itself will be forming covalent bond. In that covalent bond, shared pair of electron is shifting towards, displacing permanently, moving towards any one of the electronegative group, more electronegative group. Due to this, permanent polarity will be generating. Permanent polarity will be generating or will be forming due to inductive effect. So inductive effect is a permanent displacement of sigma electron. Permanent displacement of sigma electron towards a more electronegative group or atom. This is called inductive effect. Okay, are you getting sigma electron? Okay, so how this can also be stated like this: the process of displacement of sigma electron, the process of displacement of sigma electrons along the saturated carbon chain due to the presence of polar covalent bond at one end of the chain. So don't want to make it complicated, so make it simple. Sigma electron shifted to more electronegative group. That's it. That is called inductive effect. That is called inductive effect. It is a permanent effect. It is a permanent displacement of sigma electrons. If permanent displacement, see an X carbon with a halogen. Halogen is more electronegative. Shared pair of electron, okay, move towards halogen. Electron density increases, will be getting partial negative charge. And the carbon density decreases, carbon will be getting partial positive charge. So this leads to the formation of C plus and X minus. So heterolytic fusion means unequal cleavage will take place, no? So polarity will be generating. Okay, it is a permanent displacement effect. Okay, so sigma, here the sigma bond will be shifting, sigma electrons will be shifting. So you need to remember what is inductive effect. Inductive effect is a permanent displacement of sigma electron towards more electronegative group or atoms. This inductive effect divided into, okay, divided into two types, majorly classified into two types. So in inductive effect, the two types are positive inductive effect, plus I effect, and minus I effect. Okay, positive inductive effect and negative inductive effect. So I hope you are getting what is inductive effect. So inductive effect is a permanent displacement of sigma electron towards more electronegative group. So in that there will be two types, positive inductive effect and negative inductive effect. So we'll see what is a positive inductive effect and what is negative inductive effect. First one, negative inductive effect. Minus I effect, very familiarly known as minus I effect. Atoms are group of atom attached to bonded electron or shared pair of electrons more strongly than hydrogen atom. So carbon hydrogen atom is considered as the standard. Carbon hydrogen atom, this hydrogen bond or hydrogen atoms will be considered as a standard. Greater than this electronegativity, less than this electronegativity. So based on this will be separated. Greater, more electronegative than hydrogen or less electronegative than hydrogen. So here you need to be noticed, it is the atom or group of atom which attract the bonded electrons or shared electrons more strongly than hydrogen atom, more strongly than hydrogen atom, then it's said to be negative inductive effect, minus I effect, negative inductive effect. So what it will be? NO2 group. NO2 group, here the hydrogen, here hydrogen with respect to hydrogen, greater or less, NO2 nitrogen, nitrate group, and cyanide group, COH carboxylic group. So NO2 greater than minus, Cn greater than COOH, greater than F fluoride, chloride, bromide, iodide, R group, any alkyl group, and C6H5, any aryl group, and hydrogen. Okay, negative inductive effect. Negative inductive effect and positive inductive effect. What is negative inductive effect? Here the atoms are which attracts the bond electron more than the hydrogen atom. So more stronger than hydrogen atom, then it can attract the shape pair of electron towards themselves. So we said that between, so we took a group halogens here from chlorine to iodine, and here NO2 group. Example, with carbon and NO2 group. So nitrate group is more electronegative than carbon. So obviously, shade pair of electron shift more towards nitrate group. Then NO2 will be forming partial negative charge and carbon will be forming partial positive charge. Hence, the polarity is generated between C and NO2 group, or C and Cn group, or C and COH group, carboxylic acid. Okay, or C and F, or C and Cl. So it's nothing but which are the groups. These groups are attached. This also we can define in another way. I'll tell you based on electron donating group and electron attracting group, electron withdrawing group. These are electron withdrawing group. Okay, these are electron withdrawing group. This NO2, CN, COH, Cl, Cl, Bri, these are electron withdrawing. Electron withdrawing, they drag the pair of electrons towards themselves. If they drag the pair of electron towards themselves, then what happen? We'll be getting the partial positive charge on the carbon. So these leads to formation of negative inductive effect. Negative inductive effect. Are you getting? So inductive effect is a permanent effect, permanent displacement of sigma electron. Okay, more towards this shift, which towards which more electronegative group. What the group are attached are NO2, CnCOH. They are more electronegative than hydrogen. So shade pair of electron on the carbon shift towards these attached group. If these group are attached, they drag the pair of electron towards themselves, then the effect what we notice is negative inductive effect. Are you getting? So two types of effect in the inductive, that is negative inductive effect, another is positive inductive effect. Negative inductive effect, they drag the pair of electron towards themselves. So on the carbon will be having positive charge. This is called negative inductive effect. Are you getting? So similarly, positive inductive effect. What is positive inductive effect? Atoms, these are atoms or group of atoms. Atoms are group of atoms which attract the shade pair less strongly, this part, less strongly than hydrogen. Then atoms are said to have positive inductive effect. Positive inductive effect. So if the carbon group, example, CH3 thrice attaches to the carbon. In the case of carbon and the methyl group, all alkyl group shows in positive inductive effect. These are the less electronegative than hydrogen. So instead of dragging the pair of electron, they'll donate the pair of electron. CCH3 group attached to that carbon, if it donates the pair of electron towards a carbon, then what will happen? So if the shared pair of electron donates to carbon, then electron density on the carbon increases. If the electron density on the carbon increases, so carbon will be having partial negative charge. Partial negative charge, and the substituent group will be having partial positive charge. So you need to be noticed that the difference between the negative inductive effect and positive inductive effect. Negative inductive effect and positive inductive effect. Okay, negative inductive effect in that substituent group is more electronegative. So shared pair of electron shift towards more electronegative group, hence carbon will be having partial positive charge. Okay, in positive inductive effect, all the alkyl group CCH3 tries or CH3 tries 2, CH3 tries 2 CH3 group to carbon and hydrogen CH, or CH3 CH2 group or CH3 group. These are all the alkyl group. These alkyl group donates pair of electron, means shared pair of electron towards carbon itself, because these are less electronegative or less strongly than the hydrogen atom. If less strongly than hydrogen atom, obviously this will be getting, carbon will be getting partial negative charge and the substituent group will be getting partial positive charge. So in the decreasing order of the all alkyl group, you know that alkyl group, carbon and hydrogen group, okay, carbon, hydrogen, apart from the benzene ring, that is we call as an alkyl group. In alkyl group, the order will be like this: CH3 thrice C, okay, carbon, to this CH3 CH2. So this will be greater than CH3 twice CH2, sorry, CH greater than CH3 CH2 and the greater than CH3. So this is the order of the positive inductive effect. In this positive inductive effect, we said that earlier carbon group attaches to, so that any group attaches, example CH3 methyl group. Methyl group is electron donating group. If it donates an electron pair towards themselves, then what happens? Shared pair of electron move towards carbon. So carbon will be getting the negative charge and methyl group will be getting partial positive charge. Okay, this arises, this forms positive inductive effect. Okay, I hope you are getting the difference between negative inductive effect and positive inductive effect. Okay, negative I minus I effect and plus I effect. So it's very clear. Any carbon group attaches to any other group, if the group attached group, okay, attached group is more electronegative or less electronegative, this will be factorizes the inductive effect. Inductive effect is displacement of sigma electron towards more electronegative. More electronegative, then it forms negative inductive effect minus I effect. If the attached group are the less electronegative than carbon, then what happens? Then displaces the carbon pair of electron on the carbon. Then obviously what will happen? So which carbon will be getting partial negative charge. So there's a difference between negative inductive effect and positive inductive effect. Okay, is it clear? So in terms of electron withdrawing group and electron donating group. Okay, we'll see that. And before that, we need to see the important features of inductive effect. Okay, what are the features? How it will be considered? Whether it is a permanent effect or a temporary effect? How it affects this? Okay, important features of inductive effect. It is a permanent effect. It is a permanent effect. We notice that the inductive effect is permanent. Okay, permanent transfer, displacement of sigma electron, right? In this operation, only sigma electrons are displaced. Which are the electrons are displaced? Only sigma electrons are displaced.